Hi, everybody. I'm Shaji Nathan, and I'm with IP Infusion. So today I'll talk a little bit about, you heard about hardware. So how do you go about building networks end-to-end? Basically, exactly the same way that you could get from an OEM and deploy it for a wide variety of use cases. So what would be that operating system characteristics that you should be looking for when you build out a disaggregated solution-based network? So I'll talk a little bit about IP Infusion. IP Infusion is basically a software provider. Basically, we provide network operating systems for open compute platforms, essentially. We are headquartered here in Santa Clara. So I'll talk a little bit about the trends and challenges. So as you look at your network, right, your daily habits in particular, you would see that just about every device is getting connected to the net, right? So that means the access, be it wireline or wireless, basically needs a lot of bandwidth. And while that is increasing, on an average, you find that worldwide, basically it is almost like a 250 Mbps download speeds, right? And 25 upload is basically the norm. That's about an average. This is based on various studies. I'm not quoting one particular thing here. So essentially, when you have that kind of bandwidth that you need on a per user basis, right? And you add to it video and all the inanimate objects that are getting connected. So the access basically is getting stressed. So, and then with the 5G, you have more RAN densification. So essentially what happens is, there again, the access bandwidths are increasing. So the provider edge basically becomes more stressed now. And as the provider edge becomes more stressed, you need more fibers and essentially taking it into the data center. And in the data center, what you see is like a proliferation of applications, right? Multiple distributed applications, the traditional apps plus the new ones that are coming in, particularly the analytics one that tends to stress out the data center. So the spines, what we have seen is like the spines have grown on an average. The data center spines have grown anywhere from 100 gig to 400 gig, now 800. And the leaf nodes basically in a data center is around, started with 10, now it's 25 and 50. So essentially, that is the lay of the land. So the demands are ever increasing. But that doesn't necessarily mean that subscribers are willing to pay more. So the service provider is now in a bind. On the one hand, you basically have to provide new applications, new services, plus invest a whole lot of money. But at the same time, you also have to figure out how to make more money. And both of them basically tend to go in opposite directions. So how do you actually look at not the status quo, but how do you actually address these twin challenges, right? So let's get to that very quickly. So as you see in the exhibition floor, just about for every part of your solution, right, the access, aggregation, as well as transport, as well as for the data center, you find a platform now. And there is a network silicon that can range anywhere from 60, you can start as low as 60 gigabits and go all the way right up to terabit scale. And likewise, on the server side, there are multiple application cards, acceleration cards coming in that give you the capability anywhere from 10 gigabits all the way up to 100 gig and more. And on the provider edge side, the previous speaker talked about the distributed chassis. On that chassis, basically everything starts around the terabit scale. So you can pretty much build any kind of network today. And we have deployed over 50 new networks in the past 3 months. So in the past quarter, we have turned on, operationalized 50 new networks, actually. So how did we do that? The software becomes the key now. The hardware is readily available. There is no dispute about it. You have a fixed pipeline switch. Broadcom basically makes just about silicon for every use case. And you can find Marvell is also coming up with a competing solution. Intel has a variable pipeline solution. So essentially, programmable solutions are also there. But the key here is the software, right? Because when you take any segment, you have an existing infrastructure that is already deployed. So how do you actually start with interworking? So the service interworking becomes very important, right? So that means you need a robust control plane. A control plane that basically can support every existing protocol that is there today, because you want to take the network from point A to point B. So essentially, you need to have basic routing and switching. That becomes the baseline. So BGP becomes very important. All capabilities of the BGP, partly because at the provider edge, you would basically use L2, L3 VPN, for instance, right? That would be the backhaul solution if you're using a wireless backhaul, for instance, or a provider edge. So you start off with BGP, then ISIS, OSPF becomes very important. But at the same time, these all, the existing networks basically carry a lot of state information. So how do you scale that network with this terabit scale silicon that you have available? So you need to be able to do segment routing. So essentially be able to decouple the state information from the network, right? But at the same time, you have to start somewhere, wherever your network is today, and basically get started with that. You have to have service interworking. So BGP becomes very important. And at the same time, you want to make sure that the network operating system basically can take you into that next level, whereas decoupling state information. So being able to do SRv4, and when your network's finally ready, go end-to-end SRv6. And the other thing that you want to keep in mind is the hardware abstraction, right? Because there is a plethora of switches now becoming available. Fixed pipeline, variable pipeline, and programmable like CPUs, GPUs, right? So hardware abstraction becomes very important. Why that is very important is because from the control plane side, everything needs to remain the same, irrespective of what your network service is, right at the edge of the network, or at the access, or the transport, or at the data center. Key things are basically routing and switching doesn't change that much. But the scale and the application and the services on top of it change. So to get the maximum OpEx, right, you need to have that same operating system running end-to-end. That is what the conventional providers basically provide you. Like OEM solutions, they have end-to-end solutions. But here, you have disaggregated hardware and software. So you want to pick an operating system that basically has that proper abstraction in place. The same thing applies for the media, because there is a lot of pluggable modules that are becoming available. You can pretty much take a provider edge device and essentially convert that into a OLT device by having a plugin, and also provide a transponder and make it into a packet optical device, a routed optical device. So essentially, what you want to look for is the ability to support multiple modules. And that abstraction has to be built in. So it has to be built from the ground up, because it cannot be retrofitted later. The reason for that is like the tuning parameters, how you tune the network operating system, right? It cannot happen after the fact. So you're making those decisions for 5 to 10 years window. So essentially, you want to pick an operating system that is scalable and very easy to deploy. And last but not the least, the management plane becomes very important. You have to start with basic assumptions, right? CLI, SNMP, and some form of model-driven architecture. So netconf is basically pretty much, everybody has netconf implemented today to some extent. And in future, going, if you want to look into like 4 to 5 years ahead of time, right? As these scales increase, right, ability to troubleshoot becomes very key. So streaming telemetry becomes one of the key parameters, right? So that operating system really needs to have that hooks in place. And last but not the least, what we can do is, like, if you have a software architecture that is organized this way, you can pretty much write an application on top of it, because these are all operating systems written on top of Linux. So essentially, you can make use of the Linux container capabilities. And if those APIs are exposed, you can pretty much develop an application on top of it. What we have done in the past 6 months is basically being able to bring in microwave capability, backhaul on top of a provider edge device, being able to put in OLT capabilities, just by retrofitting this operating system. And the reason for that is you have a modular infrastructure in place, which is quite modern. And the beauty with this is you can make this operating system as sparse as possible, because these components can be delinked. You can either place it right closer to the hardware as need be, or it can be cloud deployed. Pretty much, you take infrastructure, the same infrastructure basically will go from end to end. If you want a 60 gigabit switch, it will just work just fine. You basically just have to tune it to the network silicon. And if you want a highly distributed system with the fabric and line cards that are built on a class fabric, you can pretty much do the same thing. The control plane now shifts outside. And the data plane and the management plane basically remains. The basic management plane remains. So this is, in brief, an architecture that we have actually deployed. We have basically turned on transport networks with the same operating system. We have turned on access networks, broadband aggregation, and data centers. Basically, we have over 50 networks working with this kind of an architecture. So I just wanted to give you a very brief overview as to how you could use software with the hardware that you see on the floor here today, exactly how to build an operating system that from the ground up that's tuned up for highly disaggregated architectures. So that was my presentation. It was brief, and hopefully I have time for some questions. So I'm pretty much, I covered what I had to cover. So, but I'm free to take any questions you might have. Okay, thank you very much.